For Lab 6, we're going to be looking at separating the components of a binary mixture. So the mixture that we're going to be separating is silicon dioxide and sodium chloride. We're going to be separating these two components using their solubilities. So when we say that a substance is insoluble, what we're looking at is that it is not dissolved. For a soluble substance, this would mean that yes, it has dissolved. So in the case of silicon dioxide and sodium chloride, silicon dioxide in the form of sand is going to be insoluble in water. So what that means, it's not going to dissolve in water. And you can see that because if you've ever went to the beach, you can tell ocean water hits the sand and it does not dissolve the sand. The sand is still there. Now looking at sodium chloride, the other component of the mixture. Sodium chloride, also known as table salt, it is soluble in water. So if we were to add water to table salt, we would see it dissolve. Hence the saltwater ocean at the beach. Let's look at how we're going to do this. We're going to start with a mixture of unknown amounts of sand and salt combination. That's what we're going to start with in beaker 1. We're then going to add water to that mixture. Adding water to that mixture using the solubilities we saw on the previous slide is going to dissolve the salt because salt is soluble, but not the sand. So now we're going to have a mixture of an aqueous solution with the sodium chloride in it and a solid at the bottom. So we're going to perform a gravity filtration so that we can filter out the sand from the water, separating the two. So going off to the left over here, what we're going to have as our filtrate, so what's going to go through the filter paper, is going to be that aqueous solution of the salt with the water. Notice the salt is not by itself yet. It's actually dissolved in its ions in the water. So in order to get the salt form back to a solid, what we're going to do is we're going to boil off all of the water until we get the salt in its solid form in beaker 2. So now let's look to what happened to the sand. So going off to the right, so when we do the gravity filtration, the sand is going to get stuck in the filter paper because the sand is insoluble in water and will still be a solid. So now what we have is sand on the filter paper, but it's wet sand. So that sand does have water in it. So we need to get that water off. So to do that, we're going to place the filter paper in the oven to try to evaporate off that water. Once it's in the oven long enough, the water has been evaporated, we will now have the sand, or the silicon dioxide by itself, on the filter paper. So before we do our separation, the first thing we want to do is get 2 beakers when they are dry, empty, clean, and get the masses of them. We also label the beakers so that we can keep track of what steps we're doing and what component is present in each beaker. I have the masses of beaker 1 and beaker 2 below. You can use to fill in your chart on page 43. Now for the data collection before the separation. So we weighed beaker 1 when it was empty. We have the mass of it. Now what we're going to do is we're going to add 2 to 3 grams, or it says in your lab manual, between 2.5 and 3 grams to beaker 1. So you can see that in the picture to the left. That is the mixture of the sand and the salt together. We then take the mass of beaker 1 with the sample in it and record that mass. And you'll see that it's 52.447 grams. I've also written the mass of beaker 1 when it was empty right below. It's in the same order on your sheet on page 43. So the next fill in the blank says mass of sample. So that's something you're going to calculate. So to figure that out, you'll notice we have the mass of the beaker with the sample in it, and we have the mass of the beaker by itself. So you're going to want to subtract those two numbers to figure out the mass of the sample. Because by subtracting those two numbers, you're getting rid of beaker 1 and you're left with just the sample. Next, we're going to get the mass of the filter paper when it is dry and nothing is on it. Because when we dry the silicon dioxide towards the end, we're going to be drying it on that filter paper. So we need to know the mass of the filter paper so we can subtract that out later as well. So the mass of the filter paper is 0.812 grams. So you can fill that in towards the bottom of your data summary for mass of filter paper. Now that we have masses of everything, we're ready to get started. So we're going to start by measuring 50 mils of deionized water, and that's what we have in the graduated cylinder to the far left. We're going to add that 50 milliliters of water to our sample, our mixture, our unknown mixture. We're going to then stir continuously for about 5 minutes. The reason that we're stirring it continuously is we're just trying to give time and some agitation to get that sodium chloride to dissolve. So the sodium chloride will dissolve, the sand, however, will not. It will remain in the solid state. Once we have stirred it for 5 minutes, we will then let the mixture sit and settle. So we're trying to let the sand, the solid, the silicon dioxide, settle to the bottom so that we can do our gravity filtration. This is what the gravity filtration setup looks like. We have our ring stand with our funnel, and we have placed the filter paper in the funnel to catch the sand. Notice I have a bottle of deionized water nearby to help with the transfer. I've also placed beaker 2 underneath the funnel to catch that sodium chloride aqueous solution so that we can later boil off the water and get the sodium chloride in its solid form again. So here's the gravity filtration. So how do we do it? We want to decant the liquid from beaker 1. What decant means is we're going to slowly pour off the liquid. So the reason that we let it sit and settle for a few minutes is because we don't want to put the solid sand on the filter paper first, because what that's going to do is it's going to clog the filter paper, and this gravity filtration is going to take forever. It's not going to allow the aqueous sodium chloride solution to flow through. So we want to get as much of that aqueous sodium chloride solution to flow through as much as possible before we start putting the sand in the filter paper. So we allow the filtrate, sodium chloride solution, to drain into beaker 2. Next, we can transfer the solid to the filter paper using a rubber policeman and some deionized water to help. So we're trying to get as much of the sand out as we can. We can then rinse that silicon dioxide, the sand, with a little bit of deionized water, just trying to get all the sodium chloride off of the sand. So the next steps are to take that beaker 2 that has the sodium chloride solution in it and put it on a hot plate and boil off all the water. So once that step is done, you see in the picture up on the top portion, we have now solid salt in the bottom of the beaker. No water droplets present at all. So now that we have the recovered amount of sodium chloride, we want to take the mass of beaker 2 with that sodium chloride in it. And the mass of beaker 2 with the sodium chloride in it is 64.760 grams. That's where it says mass of beaker number 2 plus NaCl dried. That's where that number goes. Next, notice we have mass of beaker 2. This is what we did in our very first step. So on the very first slide, we took the mass of the beaker when it was empty, and that mass was 64.401 grams. We need the mass of the beaker when it was empty because the next question asks us to calculate the mass of the sodium chloride when it's recovered. So this is the recovered sodium chloride after the separation. So what you would do to figure that out is you're going to subtract these two numbers, because by subtracting them, you're getting rid of the mass of beaker 2 and you're left with just the sodium chloride that is recovered. Next, we go to the silicon dioxide, the sand. So what we're going to get here is you can see a picture of silicon dioxide, and it's on a watch glass in this picture, but we are going to be massing it, or we did mass it, on filter paper. So we have the mass of the paper with the silicon dioxide, so we're massing the entire thing together, and we get 2.451 grams. So this is after it was in the oven, after all the water has been evaporated off. So in order to figure out the mass of just the silicon dioxide, we need to know the mass of the filter paper. And we recorded that mass before we did the gravity filtration, and that mass is 0.812 grams. Using those two numbers, subtracting them, we can figure out the mass of the filter paper, because by subtracting them, we're subtracting out the mass of the paper and left with just the mass of the silicon dioxide. Next, you'll notice the last fill in the blank we haven't filled for the data summary. It says total mass of NaCl plus silicon dioxide recovered. So how do you think you'll figure that out? Something you have to calculate. You want the mass of just the sodium chloride and just the silicon dioxide. So the two numbers you would use to solve that would be these masses that you calculated here and here. Simply add them together to get the total mass. So now let's look at calculations. So one of the calculations you have to do, and this is number 2 on page 43, so I went a little bit out of order here, but number 2 is saying calculate the percent of sodium chloride in the mixture. So to calculate the percent of sodium chloride, you're going to be using the following equation. You're going to take the mass of the sodium chloride you recovered, so you're going to go back to your data summary, find the mass of just the sodium chloride that you recovered, and divide it by the total mass that you recovered, so the mass of the sodium chloride with the silicon dioxide. And since it's a percent, you need to make sure that you're multiplying it by 100 to get it in a percent form. Notice when you do this division, the grams of the sodium chloride and the grams of the total mass will cancel, so the units on it is just percent. Number 1 is asking you to do the same thing, but with the silicon dioxide. So you'll take the mass of the silicon dioxide that you recovered and divide it by the total mass. Don't forget to multiply by 100 to get it in a percent form. Next, you're going to need to calculate the percent recovery. So this is number 3 on page 44. So to calculate the percent recovery, you're taking the total mass recovered. So it's the number that you used in the denominator of the previous 2 calculations. So the total mass of the sodium chloride and the silicon dioxide, what you recovered at the end of the experiment. Then you're going to divide that by your original mass of the sample. So that original solid in beaker 1, the unknown mixture that we massed. So by doing this, you're figuring out what percent you actually recovered from the original sample. So multiply it by 100 to get it in a percent form. The higher your percent recovery, the more accurate the measurements and the process in general. It won't be 100% unless the silicon dioxide was not dry. If the silicon dioxide was not dry and had water in it, then it might be over 100%. Notice these same calculations you need to do on the pre-lab. So don't forget to do the pre-lab portion and submit that with the lab portion. So the pre-lab is on page 37. The mixture that's being separated in that example is potassium bromide and magnesium hydroxide. So you will use these same equations to figure out the percent of potassium bromide in the mixture, the percent of magnesium hydroxide in the mixture, and also the percent recovery. So use these same steps. And last but not least, the percent error. So we've done this calculation several times already in lab, so we're using it again. Remember, percent error is going to be a positive. That's why these absolute value bars are present. And to calculate, you do the experimental minus the actual divided by the actual. And they actually give you an equation telling you what the experimental should be and what the actual should be. So the experimental is going to be the total amount that you recovered. So the sodium chloride and the silicon dioxide recovered. The actual is going to be the total amount or the mass of the original sample. So once you do that calculation, multiplying by 100, you should get a percent. And remember, for percent error, the lower the better. That's how much error was introduced in the experiment itself. So let me know if you have any questions. Make sure to show all your work for full credit. It says specifically in the directions to show your work. Don't forget your units, because you do get points docked off for that, and especially your significant figures. Okay, if you are subtracting, you're looking at decimal places. If you are multiplying or dividing, you are looking at the sig figs as a whole. So use those skills you learned in Chapter 1 and apply.